So with the login problem resolved, you can set off towards the airport. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area only grow on exact integer coordinates in a grid. You make a map, your puzzle input, of open squares which are represented by dots and trees which are represented by hash signs. You can see, okay, for example, this. Okay, those aren't the only trees though, due to something that you read about once involving arboreal genetics and biome stability. The same pattern repeats the right many times. Okay, so you start on the open square in the top left corner. Okay, so we start here, okay, and you need to reach the bottom, below the bottommost row on your map, so like here, right below it. Okay, the toboggan can only follow a few specific slopes. You opted for a cheaper model that prefers rational numbers. You start by counting all the trees you will encounter for the slope right 3 down 1. So 1. So how do you count this? Okay, so from your starting position at the top left, check the position that is right 3 and down 1. Then check the position that is right 3 and down 1 from there, and so on until you go past the bottom of the map. The locations you check in the above example are marked here with O, where there was an open square, and X, where there was a tree. So you go 1, 2, 3, and 1 down. Okay, and then this was an empty, yeah. And then you go 1, 2, 3, and 1 down, 1, 2, 3, and 1 down, 1, 2, 3, and 1 down. Okay, I see. So you can only go through like a specific pattern, or like through this sort of pattern. Okay. Okay, I see. In this example, traversing the map using this slope would cause you to encounter 7 trees, because we not count the number of axes, right? Okay, starting from the top left corner. Oh, so we literally need to use this thing, right? 3 down and 3 right and 1 down, and find out how many trees we hit, given the input that we get. Okay, let's download the input. Day 3, 1. Sometimes there are more different inputs for a single day. That's why I'm doing 3 times 3-1. Okay. So I guess let's just create a new file, right? Day 3. Oops. I think I want to copy this part, although I'm not sure we'll need parsec this time. Actually, let's look at the input file first. Oh, so it literally just, okay, so this is nice because we can just read it as is. We might want to like transform this into something like a sum type with like 3 and open or something. 3 open, right? Is that what they're called? Open and 3, yeah. Just so that we don't have to worry about all characters. But I mean, we can do that by just using a map. We don't have to use parsing here. Yeah, okay, we don't need parsing. Okay, so module day 3. My defaults make it such that prelude is not automatically imported, but for this we'll import it because it's easier, and it's not a very complex program, so usually importing prelude in this case is not a it's fine. So let's do, I mean, we can do parse, right? And parse could be something like an IO. Let's see. Maybe we want to create a data type, right? So map square, or let's just call it square, right? A square can be either open or have a tree, right? And we'll see whether, like, or not whether, but we'll see what kind of instances we need, but I won't start with that, right? So how do we want to do this, right? So how do you want to treat this sort of thing. Should we just have an array of arrays to represent a map, like something like this? I guess we can start with this, right? And we'll see whether we want something more elaborate than that. Okay, so we have this parse thing, right? Which, I mean, we can do read file again, which is day3.1.text. Oops. Okay. And so basically, this will give us. Maybe we can make it even simpler, right? So contents of the file is this. Let's use this syntax instead of trying to do it in a single go. Okay, so this will be like literally the whole string, right? So in order to have like right now, the contents will be the whole file, right? Which includes like all the new line characters, which we want to get rid of, and we want to like split by those new lines, and that's what lines does, right? So we could say something like let map. Well, map is probably a bad word. Let's use m for now. Lines contents, right? And now m will be a like an array of. Maybe we can even do this. And this should be correct, right? Okay. Actually, I think the correct. I don't usually do this, but I think the correct syntax is this. I think this is correct syntax. And well, I think the problem here is that I can do this. Yeah, you're right. It's actually this list of strings is what I meant, of course. Couldn't match. Hello. Is this still actually stuck? Whoa, this is the first time Vim crashes on me. Interesting. Let's try recovering. Okay, so let's try this again. Vim was completely dead, unresponsive, nothing. So let's see if that was a fluke or not. And if it was if it wasn't a fluke, then we can use something else. I think this should be right though so far. Okay, so we have this thing, right? And now what we need to do is we need to map we need a function to go from string, or rather, well, maybe it's easier to say this, right? So we need a function from so char to square, which goes like from char to square, right? We can do a case, right? So if we have a dot, we can say it's open. If we have this, then we can say it's a tree, and otherwise we can say error. We're not going to use maybes because we're kind of sure that the input is correct, right? So we just did this in this case. Normally, if you would have like in a real application, you would probably have to use a maybe here, or make this into a parser rather than any of that. So error, bad input found. Maybe we can even say what the input is. Actually, we can. It's probably easier to just do this. Okay. Right. So like we want to know what the character is, so we'll show it in that case. Okay. Wonder why it's taking so long to compile this bit. Let's see whether Cabal is having some trouble here. So anyway, well, Cabal did just fine. Not sure why the language server is not working. Maybe it doesn't like this for some reason. Well, I'll have a look in a second. Right, so here we have this M, right, which is a list of characters, right? So in order to get a list of chars, then we need to map char to square over over M, right? And that should be correct. I'm really curious what's going on with this thing, though. Let's have a quick look. Okay. Okay, day 2 worked, and then should be doing day 3. I'm don't actually not sure if it did day 1. I'm not sure what order it uses for this. Oh, maybe maybe we need to do this. Maybe we need to do that. Edit anyway, cause okay. Okay, I think it should work now. Anyway, we can continue writing. Okay. So now the idea is that we want to somehow go over the map. Okay, so there are 2 problems now, right? Why use casing when you can use pattern mesh? Because I like this syntax more than having multiple char to square lines. It's just a stylistic preference. But yeah, I could have just as well done the char to square, this equals open, and so on, right? Like one line for each. But like I don't know why. I prefer case. It's just but I think it's just a stylistic choice. I don't think it should. Okay, yeah. So it like the language server seems to be working now, although it's not telling us what lines is. So maybe it's not really working. And maybe it just crashed again. Let's give it a second. Okay, so I was saying we have 2 problems here, right? So one of them is we need to like figure out how to navigate this thing and like somehow accumulate these answers, right? So for now we only need to count trees, so maybe we only do that. We'll see. Maybe we only do that for now, right? We count the number of trees we hit as we do some sort of traversal of this of this map, right? But then the second problem is we need to repeat the map indefinitely over this, like this, right? So luckily Haskell is a lazy language, so we can actually use laziness to our advantage here, I think, right? So we could literally repeat each line forever, and that should probably not be a problem at all. Because we'll only materialize it as we need, right? We could also do some like mod, like find the length of a line and use mod and div to kind of cheat our way. But maybe we don't need to do that if in a lazy language, right? Maybe we can find a more elegant solution. That's not necessarily the most efficient, but okay, this has crashed again. Something is very wrong with with this for some reason. Okay, I'll stop trying to get autocomplete working, and we'll see if it's yeah. At worst, I have been configuring my Emacs lately, so maybe that's more stable for some reason. It's really weird because I've been using like Vim for a long time, and I've never seen it do this like on way more complex projects than this. And I guess it would be easier to add another case with less typing. Yeah, I mean, yeah, that's right. But I still think I still wouldn't say this is better, right? I would never. Okay, it has some advantages. Maybe the other is easier to read if you're used to that. I don't know. I'm just used to using case. Okay, so maybe let's start by creating a potentially infinite list of this, right? So I wonder, so without really thinking too much, if I repeat, so what's repeat actually? Let's see, what's the signature for repeat? So given an A, we get a list of A's, right? So basically, if we were to I think we need to repeat each, but then like we need to repeat but also concatenate the result of the repeat, right? Like we need something like, so we have like, let's say one row is this, right? So if we repeat this, then we'll get like a list of lists or a list of lists of 1 2 3 4 5 1 2 3 4 5 and so on, right? But then we need to fold this thing, right? And now which of the folds was the one that allowed us to use it over infinite? Was it this? No, it's the other one, right? Cycle. Oh, maybe it's cycle. Oh yeah, maybe it's cycle. And otherwise, yeah, I think it was fold, right? I always forget which one it is for some reason. Yeah. I guess cycle does the same thing. It should, right? Yeah, there we go. So we can use cycle, sure. So I guess we need to do something like, so maybe we keep the inputs unedited with like the cycle thing, and then we do something like, I mean, it's just a cycle call, so we don't need to do something too formal here. Okay, so let's say we'll just use cycle now. So now let's go back to thinking, how do we go from how do we accumulate these things, right? So for now, we don't know what part 2 is, and I don't want to over-engineer things, right? So we only really need to do a count, right? So maybe we can write a simple recursive function here. Of course, we could do a writer t and then write them there and like use some monadic code. But for now, I don't think we really need that. So maybe we can do count trees given a pattern, right? So what's a pattern? Maybe we can say we can start. Actually, I don't even want to use pattern. So let's just say we're always going to do right 3 and down 1 for now. And then we'll see if part 2, because like I don't want to think ahead because I might end up guessing what the next part is and making it easier. And then maybe it's kind of cheating. So I don't want to use that experience, that part of my experience in doing that. So I won't abstract anything more than that they seem to ask for us, right? So we'll just do something like, okay, so given a square, so a map essentially, we want to go to like count the trees that we reach, right? Count trees while moving maybe. And then we know that we're moving 3 right and 1 down, right? That's a like, okay, so if we want to move 3 down, then we need to essentially, so what we need to do is basically change we want to do a recursive call of this until we've exhausted our array, right? So we could say something like this is 0, right? Right? So we could say that if we are if we have reached the end, then it's 0, right? And maybe, okay. Well, you see, in this case, I kind of like, kind of default to this instead. Well, let's be, let's do this. When I do like recursive stuff, I usually do the other way around. But let's keep a common style here. Okay, so if we've like if we're done with the map, if we're outside the map, then there are no more trees, right? And then what are the other options? So the other options would be I am at some point, some random point here, right? Let's say, and I want to move 3 right and 1 down, right? Should I count the current position 3 and then, yeah, maybe that's a better idea. So let's see. Otherwise, we have some. Maybe we need 0 as the default case instead, like in all other cases, right? And here, let's say, okay, if I have a, so this would be a line, I assume, right? So the line you're on is the first part, and then this is like the second line, right? So this is within the first line. If on the like the current, so this is the origin, the current tree, and this is what's on the rest of it, and this is the like. So if O is we could even do something like this. So if O is a 3, then we can do 1 plus, right? So if we find a tree where we are currently are, is like move forward or something, or maybe we could do like count trees with well, we need to do something like this. So count trees, and then we kind of need to move this forward, right? So this is so we need to drop 1 line, right, from axes. But maybe we could do something like move and then axes, something like this. Why doesn't it like this though? Oh, okay, we don't need this. Okay, we can move the brackets here. Sure, that was a, oops. Sure, okay, and then we need to define move, right? Oh, thank you very much for the follow, Solis Fish CC. Sorry if I butchered it. Hello everyone. Hello. Not sure why this was caught on by Automod. There we go. Hello. Okay, cool. So now we just need to define how, I think. Well, not really. We need to do one more thing. Okay, so this is when we find the tree, and then if we find an open space, then it's 0 plus, right? And maybe you could have a different function where it takes this as an argument, and then it goes to 0 or 1, and we might do that in a second. But I think this should be a reasonable take. So where moves should be something from square to square to square, right? So move, what should it do? Well, so we need to skip, well, we can do something like this. Tail, I guess, for axis. So this is how we drop we move 1 down by this, right? When we do tail of axis, we drop the first line, so we go 1 line down, right? Which is fine. And then now it's the trickier part where we need to move like 3 to the right, which means that we need to remove, I think, 3 from like all the way down, right? Although, yeah, kind of, right? Because that's the plan. We're moving the origin rather than moving a pointer in the array, a pointer. So we could do something like map drop 3 or something, I guess. Right? Yeah, I think so. Drop 3. Well, okay, we need to do this instead. What's the problem here? So drop 3. Oh, okay. So I'm being a bit slow today. Yeah, we need this, of course. Okay, cool. And I think now it should be fine. Like we could try it in JCI before writing the actual program. We could do something like parse. Well, we need to reload, I guess. So we could say count trees. Well, maybe we need to import day 3 over parse, I guess. It says 7. I mean, let's see if that's the correct response, and if not, then we can... that's not the right answer. Okay, so we have an error. Cool. Let's see. So if it's 3, it's 1 plus. I'm curious how... Oh, yeah, I get it. We forgot to cycle, right? We forgot to cycle. That's the problem. We forgot to cycle, I think. I guess we need to map cycle, right? Okay, 234. Let's see if that's the correct answer. And if it's not, then we can stop and like think. Really? I need to think a bit more about my life choices, I guess. Okay, so let's stop for a second and think, I guess. So we forgot about the cycle, which means that maybe we need to write a solution 1, which is an IO int. So that's count trees over the parse, right? And this should be correct. So okay, doesn't just dropping 3 break horizontal looping? I don't think so, because we're mapping drop 3, right? So we're dropping 3 from each line. But like we do the cycle before that, so I think that should be fine. We do the cycle before we start moving the origin. We could even do the simplification here. So count square, which is something from square. I'm having a hard time. Yeah, exactly. Laziness makes this easier than in PureScript, for example. Case open is 0 and 3 is 1. So we can do count square here. And then replace this with an S, and then we can remove this. Right, just to simplify things around a bit. And now it should give 234 again. So let's see if... Okay, so we did get it right eventually. We forgot about the cycle because we didn't write it down, right? Which I make the mental note, which is always the right or the wrong thing to do. Mental notes never never work, right? So I should have made a note here, or maybe even wrote this down, right, before. Like when I thought, oh, we'll do cycle later. Well, of course I'll forget that because we always forget. So okay, so let's see. Time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop after all. Determine the number of trees you would encounter if for each of the following slopes you start at the top left corner and traverse the map all the way to the bottom. Okay. Okay, so we want to try different. Exactly. So this is something that I was considering earlier, right? When I said, oh, I should probably abstract for this and like have like the direction and the number of steps to be inputs to my function. And if I had done that, then this would probably be a lot easier. I think it's still very easy to do, but in the way I would have done it, I was also abstract over right and down, right? I would also say, okay, what if they want to do left? What if they also want to go up at times, right? Which might make things a bit like a bit more tricky. But apparently, it's only right and down. Okay. Okay, they produce the answer. What if you multiply together the number of trees? Oh, so we need to multiply the result of all of this. Okay, cool. Okay, so I guess we want to pass in 2 additional integers here as the how many. Yeah. So let's see, we want to take as input the like right and down, right? Okay, and right, so right was 3, right? So this would become drop right, correct? And this needs to be drop top rather than tail, right? Because tail is drop 1 essentially. So we need to drop top, right? And here, instead of this, we could say right is 3 and down is 1, right? And hopefully we should get the same result. Oh, wait, it's the, drop. Hello, it's drop, not tail. Could you please update? Oh, wait, it's, okay, sure, if you insist. So int to, oh, it's, okay, it's down. What am I even typing here? It's funny because this still says tail here. Okay. Move access. Couldn't match expected with actual type square in. Oh, right here. Right. We need to also pass right and down here, of course. Okay, and now we can run this again to make sure that we still get the same number. Well, actually not this one, solution 1 rather. 234 does the same thing, so cool. We did not break anything. Okay, so solution 2 needs to be something like this. So we need to find all of the answers of running each of this thing, right? So let's just do syntax just to keep things simple, right? So map, well, let's call it, I hate this thing. What's a different word for map? Like terrain, let's call it like this, is parse, and then let's do map cycle here, right? So this is the terrain we need to navigate, and then we can just call yeah, we can maybe do a zip. Okay, again, I'm going to the land of complicating things, so okay, so let's do attempts is what? Count trees while moving. It's 3 down. Wait, no, it's 1 and 1, right? 1, 1 with terrain, right? And then let's just do this, right? I don't want to overcomplicate things. I said I'd keep things simple, so let's keep good on that promise. And then the second one is 3, 1. 3, 1, and then is 5, 1, and then we have 7, 1, and then 1 down, 1 2, sorry, 1 2, right? So they're all 1 except the last one, and then 1 3 5 7 1, 1 3 5 7 1. Okay, cool. Okay, so these are all the attempts. So now the result should be multiplying these results together, right? So product of attempts, right? Pretty sure that's all we need to do. Oh, and I've been a very, very naughty Haskeller. There we go. And the result is this big number here. Let's see if that's the correct results. There we go. So even if we didn't think about it from the beginning, it didn't end up being too hard. The main thing here, which Haskell really helped, was cycle, right? And laziness, but like indirectly, right? Cycle and indirectly laziness. Because otherwise it would be like, I would assume in languages where you don't have laziness, you have to like fake it with maybe mod and div and things like that to like cycle integers rather than cycle your actual map, which is, yeah, I mean, it's not necessarily a terrible thing to do, but I think this helped keep the solution very easy. Right. For example, we could have even done something to make it even like instead of 3 and open. Hello, welcome to the stream. So this would have like we could even use an integer instead of a square, and we could say open is 0 and 3 is 1, and then we could like not need this because it would just add it there. But I prefer having like this more descriptive types. And again, we didn't know what they would ask us to do, so maybe this is a better solution overall. It's easy, but it's probably very inefficient. Yeah, probably. But again, the point of what's it called? The point of this stream is to keep it simple, and I think an efficient solution would not necessarily be as simple anymore. I do wonder though how inefficient it actually is, and maybe that's something we could do in a different stream where we can actually